Bill Hunt. I'm the CTO of Dynamic, and I'm going to give you an overview of our FogLAMP product. Now, FogLAMP is an IoT platform designed specifically for industrial use cases. There's lots of reasons why you'd want to collect industrial data, but some of the main drivers tend to be predictive maintenance, so that you can do maintenance only when required and reduce costs and increase the efficiency. And also overall equipment effectiveness to ensure that you have high quality things that are being manufactured. And of course, some of the overall goals are always improve quality, improve efficiency, improve safety, and reduce environmental impact. So some of the things that FogLAMP does, ultimately it's all about collecting data. So you can collect data from any kinds of sensors. You can transform it, you can filter it along the way and make it more meaningful. You can buffer it, so if it's in a haul truck going through a mine or out on an oil rig, and you lose connectivity, you don't lose any of your data. It has an event engine, so you can take action out on the edge, and you can visualize the data out on the edge as well. And of course, you deliver the data to one or more locations. Now, a single FogLAMP can do all those things. You hook a sensor to it, hook it to a Pi server, for example, and the data just flows. But you can do other more complex things with it. So you can have multiple sensors, you can have multiple destinations, you can send FogLAMP data from one FogLAMP to another FogLAMP so that you can build these hierarchies or meshes of these. It can be installed in a redundant pattern such that if your hardware fails, you don't lose anything. And this enables you to build varying degrees of complexity across your applications to solve the sorts of problems that you might have. FogLAMP runs on any variant of Linux, and so it runs typically in industrial gateways like the ones at the bottom by folks like Advantech or Nexcom. There's a company called SmartCone on the left that makes servers that mount on telephone poles, can run in Cisco routers and containers or other kinds of containers as well. It can run on a Raspberry Pi, so you could use it to do development on the Raspberry Pi and then roll it out to something more industrially rugged. Or if the condition warrants it, you could roll it out on a Raspberry Pi since it's so inexpensive, and then you have the equivalent of a very practically disposable sensor that you roll out, and if it breaks, you replace it with another one. A couple of use cases. We have many use cases out there, but a couple. This is in power transmission and distribution. They're collecting at substations. They're monitoring the transformers. The temperature and the surrounding temperature as well. And they're running this inside a Cisco device, inside a Docker, and inside a container. And they're sending data to multiple locations. They're sending it to their OSIsoft Pi servers and also via Kafka to a trouble ticketing system. So when they detect problems, they can do truck rolls. This is a mining company. They're monitoring slurry pumps. They're monitoring vibration and current. They're also monitoring leakage, and then they're doing predictive maintenance. So they're looking for the failure of bearings and getting notified when they think those will happen, and also notifying if cavitation is occurring. This is the architecture. So all these pieces fit inside a gateway, which is FogLAMP. And the data flows from the south to the north. So from the south service through the storage layer, out the north service to whatever destination it's going to. The blue boxes are plugins, and so they're kind of a core concept in FogLAMP. The idea is there's many of these plugins that are available off the shelf, and so you can build pretty much everything with it. But if what you need doesn't exist, it's very easy to create your own, whether you as a customer does or whether a system integrator does, or we at Dynamic can help you with that. So at the south side, there are south plugins for different types of sensors. And then the data flows through filters, either on the south side or on the north side. And typically on the south side, you would do filtering to transform that data. So for example, you could do RMS or FFT for vibration data. You could do image classification. You could do simple things like converting Celsius to Fahrenheit or much more complex sorts of things. Then on the north side, you can also have filters where you have perhaps you're compressing the data or only sending a subset of it or only the deltas. And then ultimately the data is flowing out to like Pi via OMF or Kafka, Splunk, GCP, many others. There's a rule engine in the upper left, and that has rules and actions. So the rules can be as simple as saying if the temperature goes over this, then I want to take an action, or it could be much more complex if you have, for example, an autoencoder ML rule that just looks for anomalies. And then the actions, the typical actions are to create data and send it north to let some other system know that something has occurred. But you could also run an external app on the FogLAMP itself to turn off a machine or to flash a light, that sort of thing. There's an orchestrator that manages the whole device, and it's got some very self-healing capabilities, so it's very robust. And then the whole thing is accessible via GUI. And then also the GUI leverages the REST API, so you can use other tools or other management consoles you can tie it into because the whole thing is open. FogLAMP is really good at processing vibration data. So you can collect data and see it in context with other data. You can send snapshots. You can do various enriching of the data. And you can do conditional forwarding where you only detect anomalies and send the last 5 minutes of data to conserve bandwidth. You can do machine learning. We look at machine learning in two ways. There are intelligent sensors, so you can have a camera on FogLAMP that points at a weld, say, and detects the quality of the weld, or you could have a camera that points into an area where there shouldn't be people, and if it sees a face, then it notifies someone. And then we also look at machine learning in the rules engine, where you can have an anomaly detector that detects if a machine is healthy. We have Google TensorFlow Lite ported into FogLAMP, and so you can run various models there using that. And it also can leverage Google's TPU technology, which is a hardware accelerant. And then FLIR is a thermal imaging company. They're the largest IR camera company in the world. You can point a FLIR camera at a shop floor and draw bounding boxes around important pieces of equipment, or you could point it at a single piece of equipment and draw bounding boxes around areas of interest on that piece of equipment. And then you can get min, max, and average temperatures in those bounding boxes. FogLAMP is open source, so the open source version is known as FLEDGE. It's part of the Linux Foundation, and the Linux Foundation has an LF Edge division, and FLEDGE is the name of it, which stands for FogLAMP Edge in the Linux Foundation. And you can see there's some great names that we have as partners there to ensure that it's always going to be robust, always available for you. So that's FogLAMP. Hope this has been valuable. And if you have any questions, please reach out. Thank you.